Hello and welcome to our demonstration of the mass transit simulation system for CS2340. The MTS application simulates the interaction of vehicles and how they move between different locations along various routes. In this phase, we have added discrete event simulation capabilities to the system. Specifically, this includes the ability to process individual simulation events, advance logical time, and track when vehicles move between locations along their assigned routes. So before going into the code, I'm just going to give an overview of the diagram. So before, in phase one, we just had the MTS system with all the methods overviewing all vehicles, locations, and routes. But in this phase, we separated it into individual service objects to manage their corresponding entity and all the entities that exist of that type. So for example, we have vehicle service that manages all the vehicles, and then has all the vehicle methods. And then each of these is able to reach a different service through the MTS because the MTS references the service and the service references the MTS. They all can access one another through it. And then this relationship is the same as phase one, except for how vehicle can complete 0-1 events at a time. So going ahead and jumping into the code. So for phase one, establish the core domain objects, vehicles, locations, and routes. So phase two builds on top of that by adding 4 key capabilities. So the first one is in location service. We have set distance. So the set distance method stores distances between pairs of locations in a hash map on each location object. This distance is stored bidirectionally, so setting the distance from stop 1 to stop 2 automatically stores it in both directions. And then the method validates that both locations identifiers exist with the contains key, and then the distance is positive before storing anything. So that's here. In vehicle service, we have a set vehicle speed method, which validates that the vehicle exists and that the speed is a positive value before updating the vehicle. Also in vehicle service, we have a calculate end time. This method takes a vehicle, gets the distance to its next location using the vehicle's own next distance method, which is here and here. Basically by getting it's an auto method, and then what it does is it divides its speed to get divides the distance by the speed to get hours, converts it to minutes, and uses math.max to enforce the minimum of 1 minute. This result is added to the current logical time to produce the absolute arrival time. We also have get vehicle ETA. So this checks 3 possible states a vehicle can be in. If the vehicle has no active event yet, it is sitting at a location waiting. The system returns its current location. If the vehicle has an active arrival event, meaning is departing is true, it is in transit and the system returns the destination and expected arrival time. If the vehicle has a departure event, meaning is departing is false, it is dwelling at a location and the system returns the location. Vehicle status similarly checks whether a vehicle is between 2 locations or sitting at one, using the active event to determine which case applies. So getting into the discrete event simulation itself, which is mainly in event service. This maintains the priority queue of events ordered by end time using the comparison method on event. So we have one of the main methods here is populate events, which is it scans all the vehicles and creates initial arrival events for any initial events for any vehicle that has no current event and has complete data, meaning it has a route with at least 2 stops, a valid speed, and a known distance to its next location. We have process event, which pulls the next event from the queue and handles 2 cases for an arrival event and moves the vehicle to the new location, updates the location's vehicle list, advances the route position, schedules a departure event 1 minute later, and if it's a departure event, it removes the vehicle from the current location and schedules the next arrival event using calculate end time to determine when it will arrive. Advanced time repeatedly calls process event in a loop until either the queue is empty or the next event's end time exceeds the target time, then sets the logical time to the target and reports all processed events. So now we're going to see this in action. And for that, we have a sample input text, which basically is going to go through basic setup, creating vehicles, creating stops, creating a route, assigning the stops to the route, assigning those vehicles to the route. Then the event simulation commands time show, setting the vehicle speeds, setting the distances, doing some ETA and status checks, and then event processing with event next, event process, time show. We'll do that for both departing and arriving. And then we'll showcase the time advance feature, and then finally we'll end with some error cases, creating like duplicate uh, objects with the same ID, and then doing like negative values, invalid vehicles, um, and yes. So let's go ahead and get into it. Hold on here. Call that and then do it. I did the wrong slide. How did that not work? There we go. Okay. So, as stated before, the first few parts is the basic simulation setup. So this was covered mainly in the last phase. So I'm going to skip through most of it. We created 3 buses, 3 stops, the route, and assigning all those to the route. Um, Next, we need to configure the speed to our vehicles and distances between our locations. Hold on, never mind. We're going to do this first. So the first thing we do is time show, which shows the current logical time is 1. That's the starting time for our simulation. We also do 3 set vehicle speeds, all to 60 kilometers an hour for each of the vehicles, as well as setting the distances between each of the stops as 10, 20, and 30 kilometers. And the system will use these values along with the vehicle speed to calculate travel times using the formula travel time equals distance divided by speed, expressed in minutes, and truncated to the nearest minute with a minimum of 1 minute. Um, We also have ETA and status checks. So before we start processing events, we can check the status and estimate arrival times for our vehicles. Um, so we have vehicle ETA for each of the vehicles, and so the ETA command shows us the vehicle's current state. And since no events have been processed yet, both buses are sitting at their starting locations with no active events. So the system reports their current location. But once some events are in process, this command will show the destination and expected arrival time for vehicles that are in transit. Similarly for vehicle status, the status command tells us whether a vehicle is currently at a location or in transit between locations. So right now, both buses should be at their assigned starting location. So now for some event processing. Um, this is the core capability of what was added in this phase. So the first one is the next event. So the next event next command shows us the next event that will occur in the simulation in chronological order. This could be a departure event, meaning a vehicle is about to leave its current location, or an arrival event, meaning a vehicle is about to arrive at its next location. Notice the system shows us the time, the type of event, the vehicle involved, and a location. Um, the event process command executes the next event and updates the simulation state accordingly. So the vehicle departs, its current location is marked as in transit, and a new arrival event is automatically scheduled at the correct future time based on the travel time calculation. Um, so we can actually see this in the diagram, the sequence diagram for when a vehicle is finishing its departing event and arriving at a new location. So we have the travel controller asking the user for its command. One of these 2 commands could trigger an object or a vehicle arriving at its location, either process event or advancing a time. where the one of the events is the object or vehicle arriving. Both of those will trigger process event. Basically, what occurs, it populates any events of vehicles that don't have an event yet. It dequeues the next event, which will be our arriving event. Gets the vehicle as part of the event. Gets that vehicle's location. Gets the end time. Removes it from the list of vehicles in the previous location if that exists. Sets the vehicle's location to the next. Sets the vehicle's location to the next location that it's arriving at. Um, it's here and updates its position, and then finally it creates the next event for that vehicle, which would be that 1 minute event called the arrival event. And then we see here, because we set the event and we dequeued it up here, the departing event can no longer be referenced, so its lifeline ends, and while this lifeline begins, uh, and then we add that event to the queue. And before returning uh, the text for the user to see. Going back to the code, where was I? So we also have time show again, which the logical time has been updated to reflect when the event has occurred. Notice the time has advanced the departure time that we just processed. The next event in the queue is now the arrival event that was automatically created when we processed the departure. And so we're going to process that as well. The vehicle has now arrived at its next location, and the system has updated the vehicle's current location and route position accordingly. And then a new departure event will be scheduled from this new location. So that's all here. And then finally with the time show, so the logical time has advanced again. But that's here. The logical time is again advanced to reflect the arrival time. This here is the advanced time that we get to now. So then rather than processing events one at a time, the system also supports advancing the logical time forward by a specified number of minutes and then automatically processing all the events that occur during that time period. This here was the time advanced 30. So we have advanced the simulation by 30 minutes. The system has automatically processed all events that were scheduled to occur within that 30-minute window. This includes departures and arrivals for all vehicles on the route. Notice the system displays each event that was processed in chronological order. We have an arrival, departure, arrival, departure, departure, arrival, all occurred within that 30 minutes. And then it shows how much time was, or the new time, since the old one was 12, it advanced 30, so it's now 42. And then we can time show it's also now, logical time is now advanced by 30 minutes from where it was. And we can now check the status of our vehicles to see where they ended up after all those events were processed. Um, So now finishing with that, the demo, we're going to go into the error cases. So the simulation also needs to handle invalid inputs gracefully. So we're going to demonstrate that it can correctly detect and request and report errors without modifying the simulation state. So some of these are basically the phase one errors, which are still here. We have the creating a duplicate, or creating a vehicle with a duplicate ID, as well as location and route. Here is a new one, which is creating or setting a speed to a negative value. So negative speed is invalid, so the system alerts us and does not modify +1 speed. A similar thing occurs to the distance. Since a negative distance is valid, it's correctly rejected. This is for setting the distance. So when a location identifier in one of the two parameters for setting a distance is invalid, it will say that the invalid stop doesn't exist. So the system detects this and rejects the command. A similar thing for vehicle ETA and vehicle status is the vehicle does not exist, so it correctly reports that the invalid vehicle does not exist. This is for time advance, so the system this is a negative value, and the system does not allow rewinding logical time, and so the advance is rejected. It shows that the system only moves forward. This is for showing or adding stops to a route out of the index of the route. So if this index is 99 is out of bounds for route A, which only has 3 stops, so it's correctly rejected. And then assigning that bus, trying to attempt to assign that bus to that route also shows its invalid index, or trying to assign a vehicle to that index also shows its invalid index. Finally, here we create a bus 4 and assign it to our route, but never set its speed. So when we request its ETA, the system correctly reports that it cannot calculate a travel time without a valid speed and reports this appropriately. And then here we create bus 5. Bus 5 has no route assigned at all, so the system correctly identifies that it cannot calculate an ETA for a vehicle with no route assignment. And so that is the end of the error checking. So that about concludes our demonstration of the mass transit simulation system for this phase. To summarize what we've shown today, we've shown setting up the vehicle's locations and routes, but mainly configuring the speeds and distances for travel time calculation, processing individual simulation events using event process, advancing logical time using time advance to process multiple events, and then the error handling. And we also showed how the diagrams also demonstrate this, and then we showed the system quickly implements a discrete event simulation as specified, tracking vehicle movements between locations and accurately calculating travel times based on distance and speed. Thank you for watching.